Hi. Today we're going to talk about two different types of problems or two different problems. We're going to have problem A about Carolyn who rode her bike, and then we have problem B, Bob eating hot dogs. Please make sure we're both looking at the same side of the paper. I know yours is much smaller than mine, but we're going to talk about Carolyn rode her bike 50 miles in 5 hours. The first thing we need to do is find her rate of change. What that really is referring to is what is her speed. As I go through this, whatever I write down, I need you to write down. These will be your notes. They will be very helpful as we progress. Okay, what we know going back to this is she was able to go 50 miles in 5 hours. The question is then, how many miles, when we don't know something, we use the variable, did she travel in 1 hour? In our last unit or two, when we were looking at similar figures, we would do cross product where you would multiply diagonally and then divide. Some of you are able to look at this and instantly get the answer. So if I first did cross product, 5 times x is 5x. 50 times 1 is 50, and then we divide by 5 and we get x. She is going 10 miles per hour. Sometimes you'll see it written as 10 miles per hour. This one I know is very straightforward. You would say to yourself, to go from 5 hours to 1 hour, you would divide by 5. So then across the top, you would also divide by 5. Either works. But what we have is her riding her bike at a rate of 5 miles per hour. Now, the key and something that you need to remember at the beginning, she is starting at time 0. So she did not travel anywhere. So she's also starting at 0 miles traveled. Then we're going to say, okay, she rode her bike for 1 hour. She was able to go 10 miles. Then she rode another hour, not getting tired, constantly traveling at the same speed. She then would be at 20 miles from her starting point, whether it's at home, her friend's house, and we would add another 1, which means we would add another 10. For every hour we add here, we have to add the 10 miles she is able to travel. So if I add another 1, I have to add another 10 miles traveled. Add another hour of riding. She's amazing. She never slows down, never gets tired. We have then in 5 hours, she was able to travel 50 miles per hour, or 50 miles, excuse me. Now we're going to sketch the graph of her travels. There's a lot of details that need to be included on this graph. When we're graphing things, you're given a table often. X goes on the horizontal axis. This will be your independent variable. We cannot change time. The length of an hour will always be the same. The length of a minute will always be the same. So time is your independent variable. So we'll write the word time across the bottom. On this one, we always start with 0 in the corner. And we have to count by a constant rate. So I'm going to do skip counting because we really only need to go to 5. And I don't want just an itty bitty graph. So I'll start at 0 and then skip to 1, skip to 2, skip to 3, skip to 4, skip to 5. I'll give you a minute to get caught up. I feel I might have talked really fast. But again, as you're doing this, please verify you have 0 in the corner and there's equal distance between all of your numbers. On mine, I have 2 rows and then the number 1, and then I have the 2 rows and a 2, 2 rows 3, 2 rows 4. Very important you have the same spacing. Now, on the Y, this is going to be the total distance, traveled. Notice I left some room so I can label my numbers here in a minute. I'll let you get caught up. The unit that we used is miles. You can abbreviate MI if you want. Like I said, I know I'm working with a much bigger piece of paper than you. I also got this information right from the table. Tables and graphs, they go together. When we are looking at how do you set up a graph given a table, it will often label it for you. Hours will be on the X and the miles will be on the Y. Okay, again, because we only need to go to 50, I'm going to make sure 0's at the corner, and I'm going to skip count, go to 5, skip to 10. Nah, that is not true. Erase, erase, erase. It won't fit if I do that. My apologies. I really want to count by 5s, but I'm going to label every other line. Sorry about all that. I'll give you a minute to erase to get caught up. I'm going to do 0, skip to 10, then I'll skip to 20, skip to 30, skip to 40, skip to 50. Now let's take a minute and look at our graphs. This isn't a trick question. This is just one I want you to think about because we're going to be asking ourselves this quite a bit. On the y-axis, I labeled every other line 10, every other line another 10, every other line another 10. What did we really count by? If I had to fill in all the lines I skipped, what did I count by to go from 0 to the first to the next? All right, we really counted by 5s. That would be 5, then we'd have 10, and then 15. Sometimes on graphs, they do not label every line. Graphs are too small, maybe too smushy, hard to read. So let's take a minute. When we go back to our x-axis, I did 0, skip to 1, and then we skipped to 2. If I asked you to label every vertical line, what did we count by? Well, we would have counted by halves because there's halfway and 1. Then it would be 1, 1.5, 2, 2.5, 3, etc. Just sometimes with graphs, you don't label every line, it gets too messy. Now, using the data points, we've been practicing our ordered pairs. Remember, X comes before Y. Your X will tell you your left and right. Your Y will tell you your up and down. In this case, we're working with all positive numbers, so we're really just using the first quadrant. At time 0, Carolyn is still at home, so we have a ordered pair at 0, 0. After 1 hour, she has traveled 10 miles, so I start at the origin, I move to 1, and I'll move up to 10, and I put my ordered pair. Now, after 2 hours of traveling, she was able to get to 20 miles, so there's another 3, up to 30, 4, up to 40, and 5, she made it 50 miles. Doing the best you can, draw a straight line that travels through these points and goes a little beyond. Straight lines continue forever and ever. There's a few things I want to talk about in terms of looking at this graph. This is known as a linear graph. I know it is linear. It has the word line in it. Notice how it makes a perfectly straight line. So it is linear. Straight. Not a curvy line. We'll deal with those like we did in the past when we would have some curvy lines. This is perfectly straight. A couple other features that I want you to make note of when you're looking at a graph, the points. When I'm referring to points, I'm talking about the X and the Y that we graphed from the table are equally spaced. I know it's hard for you to fit all of that in your tiny little piece of paper, but I trust you're doing a great job. Finally, when that happens, you have a constant rate of change. When you look at a graph, if you see it makes a straight line, it is linear. If the points are equally spaced, it is linear. And then it also has a constant rate of change. So let's look at these a minute. If I were to pick 2 points from our 2 ordered pairs and connect them with a triangle, what I noticed is from here to here, this is 10 digits tall. To go from row 30 to here, that was 10. To go from 3 to 4, that is 1. If I connect these points here, we started at 10, and that line goes to 20. That means it is 10 tall. Here, we started at 1, and we went to 2. That is also 10 tall. Oops, nope, sorry, 1 tall. I can't erase this. So it changes for every hour. That person is moving 10 miles. I'm going to let you pause the video a moment. Make sure you have everything written down that I have on mine. Please pause the video. Make sure your notes look like mine.